Hello everyone, this is Prashanth, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Now I am going to explain second protocols like IEEE 802.11 Wi-Fi. So in the previous session, we discussed in the last two sessions we discussed introduction of IoT and applications, along with some applications and advantages, disadvantages, challenges we faced in 2020 IoT devices, like that we discussed. So in the last one, we discussed about the first protocol, that is 802.3 Ethernet protocol. So what are the process of frame format of 802.3 Ethernet? What are the classifications of 802.3 Ethernet? For example, these having two types of 802.3 Ethernet. One is nothing but classic and classic Ethernet and scheduled Ethernet. So this is the topics we discussed in the last session. So now we move on to the second protocol, that is 802.11. It is nothing but Wi-Fi in the link layer. So let's the first one is 802.3 Ethernet is over. Now we are play with 802.11. Officially it is called Wi-Fi. So before that, first we have to know the basic concepts of Wi-Fi and the technical name is 802.3. So it is, what is Wi-Fi first? So Wi-Fi stands for wireless fidelity. It stands for wireless fidelity. Wi-Fi has it based on the IEEE 802.11 family of standard, and it's primarily is local area network. It is a local area network technology. It's designed to provide inbuilt broadband coverage. So next, the current Wi-Fi system support a physical layer data rate of 54 Mbps. So the maximum range of Wi-Fi is in terms of Mbps, that is 54 Mbps, and typically provide indoor coverage over a distance of 100 feet. 100 feet. So Wi-Fi has become the de facto standard for last mile broadband connectivity in homes and offices and public hotspot locations. So this is the main advantage of Wi-Fi over WiMAX or 3G in its wide availability of terminal. So it provide coverage range of only about 100,000 feet from the access point only. So we can connect the device from in the range of 1000 feet as per our availability situation areas. So this is about first, what is Wi-Fi? It stands for wireless fidelity. It is based on the IEEE 802.11 family. So based on the local area network technology. So the physical layer data rate of 54 Mbps. The main advantage of Wi-Fi is over it coverage range of only about 1000 feet from the access point only. So this is the figure as just example for Wi-Fi. Next, move on to the duplex communication. So generally in the communication, every access points or every devices can follow the two types of duplex system. One is the half duplex and full duplex. So here we play with Wi-Fi. So the Wi-Fi belongs to half duplex communication system. So generally the what is the main difference between half duplex and full duplex? So in the half duplex, we are sending the information from the transmitter to receiver. In is the only one-way communication, is nothing but half duplex. But is coming to full duplex, it is the sending the information from transmitter to receiver, as well as the information is sent from the receiver to transmitter only. So it is the two-way communication. So one-way communication is nothing but half duplex. Two-way communication, transmitting and receiver communication is belong to full duplex communication. So but here the Wi-Fi is based on half duplex communication. So all the Wi-Fi networks are connection based on TDD system. So here TDD is very, very important, time division duplex. So time division duplex, it follows time division duplex communication. So time division means what? So for example, 120 milliseconds to transmit some amount of signals. So the time slots is divided into as per our slots. So for example, the channels are 4 channels. So 120 milliseconds by 4, that is for one signal 30 milliseconds. So the time slots divided into how many number of channels it available, depending on that it can divide it. The time slot is divided. So the based on this concept it is working. So time division duplex, where the access point and the mobile stations are Y for the use of the same channel. So because of the shared media operation, all Wi-Fi networks have half duplex. So one more, they are equipment vendors who market Wi-Fi mesh configurations, but those implementation of incorporate technologies that are not defined in the standard Wi-Fi protocol. So this is about half duplex communication Wi-Fi. So everyone how to remember one thing here. So the connection is based on time division duplex, is nothing but half duplex. It follows half duplex communication to transmit the signals from one place to another place. So this is about half duplex followed by Wi-Fi. Next, move on to the Wi-Fi working concepts. So this is very important thing. So working concept is nothing but based on that areas, or based on that modules, or based on that as per our requirement. So here I mentioned 3 working concepts of Wi-Fi. The first one is radio signals. Based on the radio signals, we can transmit the signals from one place to another place. Is nothing but, for example, there is a mobile. So in this area, Wi-Fi is available at every point. So when I entering into this area, automatically the Wi-Fi is connected to my mobile. So because of the signals passing in the entire the room, so the signals is nothing but radio signals. So here one of the working concept of Wi-Fi is radio signals. So the radio signals are the keys which make Wi-Fi in Wi-Fi networking possible. These radio signals transmitted from Wi-Fi antennas are picked up by the Wi-Fi receiver. So the transmitter can transmit the signals within the range, within the given time slot only. So the same process will occur at receiver also. So the receiver also, it receives the signal, radio signals up to the allotted time slot only. So such computers and cell phones that are equipped with the Wi-Fi cards. Whenever a computer receives any of the signals within the range of Wi-Fi network, which is usually 300 to 500 feet for antennas, the Wi-Fi card reads the signals and thus creates an internet connection between the user and the network without the use of a card. So this is the first working concept of Wi-Fi by using radio signals. So generally the communication is going on in between the devices is signals. So the signals is nothing but radio signals. This is the radio signals transmitted from the Wi-Fi antenna. This is the first concept of working concept of Wi-Fi, that is radio signals. The second one, Wi-Fi cards. So we are unable to see Wi-Fi cards in some situations. So particularly, just think Wi-Fi cards as being invisible cards that can connect your computer to the antenna for a direct connection to the internet. Wi-Fi cards can be external or internal. So that's why. So in some cases it is not available inbuilt. They attach to the either systems or any other Wi-Fi devices. If a Wi-Fi card is not installed in your computer, then you may purchase a USB antenna attachment and have it externally connect to your USB port. So by using USB port, we can connect to the Wi-Fi card to our system or any other our device. So for laptops, this card will be PCM CIA card, which you insert in the PCM CIA slot on the given on the laptop. So this is the second working concept of Wi-Fi cards. So next, move on to the third concept of working concept of Wi-Fi is hotspot. So the hotspot is created by installing an access point to an internet connection. The access point transmits a wireless signal over a short distance. So within the range, for example, so there is a two mobiles are available. So in one mobile, this is in this mobile internet is available. In second mobile is not available, internet is not available. So in the first mobile, there is a option for switch on hotspot. So immediately the data will transmit to the second mobile. So immediately the second mobile is get Wi-Fi connection from the first mobile. So this is the option of hotspot. So most hotspot are located in places that are readily accessible to the public, such as airports, coffee shop, hotels, bookstores, and campus environment. So this is about the third working concept of Wi-Fi, that is Wi-Fi concept. The first one is radio signals. Through the radio signals, we can transmit the develop the communication. Second one is Wi-Fi cards. It is attached to the mobiles or systems or any other devices. Next one, Wi-Fi hotspot. It provides at the place of airports, coffee shops, hotels, bookstores, and campus environments. So next, move on to the standards of IEEE 802.11. So here it is very important. So IEEE 802.11 standard defined through the several specifications of wireless local area networks. So it defines over the air interface between a wireless client and the base station or between the two wireless client. So what are the standards? So here IEEE 802.11 is the first standard. Second one is 802.11a. The third one is 802.11b. Fourth one is 802.11g. So here we studied four types of IEEE standards. So four types of IEEE standards having different protocols, different specifications, different advantages, disadvantages, different applications it can develop. Based on our requirement, we can use IEEE standards starting from 802.11a to 11g. So let's see, the first one is 802.11. This pertains a wireless LANs to provide 1 or 2 Mbps transmission in the 2.4 gigahertz. 2.4 gigahertz in the within the range of frequency band, we can provide 1 or 2 Mbps transmission using the spread spectrum communication, that is frequency hopping spread spectrum. It is very important concept. FHSS, frequency hopping spread spectrum, is very important concept. So for example, there is a spectrum for AM, amplitude modulation AM. This is the spectrum of FC. This is 0. So when you spread the spectrum means number of availability of users is more increase. So basically the spectrum size is very limited. So for example, 100 users can access the spectrum initially. When you spread the spectrum as per our requirement, the connecting users are more. So apart from that, it is one of the advantage. So based on that, the concept is frequency hopping spread spectrum or direct sequence spread spectrum. So these two concepts comes under 802.11, frequency hopping spread spectrum. So the transmission is going in between in terms of hops, frequency hops. That's why it is called frequency hopping spread spectrum. When you spread the spectrum as per our requirement, the connection, the number of availability users get increase within the spectrum. So this is about the first standard 802.11. Next, move on to 802.11a. So this is an extension of 802.11. It pertains to wireless LANs and goes as fast as 54 Mbps. But here 1 or 2 Mbps transmission in the 802.11, but in 802.11a it is fast as 54 Mbps within the range of 5 GHz band. it employs orthogonal frequency division multiplexing. So the multiplexing technique is very, very important one. Multiplexing. We can more number of signals can pass through single channel. Single channel only is nothing but multiplexing. So based on the concept multiplexing, we have TDM, FDM, WDM, OD, orthogonal frequency division multiplexing. So initially we have these 4 types of multiplexing techniques in order to pass more number of signals can through the single channel. But here 802.118 it is the employs orthogonal based on orthogonal frequency division multiplexing encoding scheme as opposed to either frequency hopping spread spectrum or direct sequence spread spectrum. So this is about orthogonal frequency division multiplexing. It employs 802.118, the second standard. Next, move on to the third standard, 802.11b. It is the high rate Wi-Fi. It is an extension to 802.11 that pertains wireless LANs and yields a connection as fast as 11 Mbps per transmission in the band of 2.4 GHz band. It uses only direct sequence spread spectrum. It employs direct sequence spread spectrum. So the last standard is 802.11g. This pertains to wireless LANs and provides a 20 plus Mbps in the 2.4 GHz. So these are the 4 types of IEEE standards of 802.11, IEEE 802.11, 802.11a, 802.11b, 802.11g. So these are the 4 different types of IEEE standards. Let's see comparison. Comparison of technical comparison of 3 major Wi-Fi standards here, 11b, 11a and g. So 11a and 802.11a is similar to 802.11g. So the almost the applications are the technical comparison parameters are almost equal to 802.a and g. That's why I mentioned in the first one, second one compared with B. So the first feature, primary applications. The primary application based on wireless LANs, it is also called wireless LANs. Next, in the second feature, frequency band. So there is a compulsory, there is a difference in frequency band for 802.11b 2.4 GHz. This is for 2.4 GHz for G, 5 GHz for A. Next one, channel bandwidth 25 MHz for 802.11b, 20 MHz for 802.11a or G. So almost similar for 802.11a and G. The next feature of standard is either it is half duplex or full duplex. We already know. So the Wi-Fi standards all are comes under half duplex only. The one-way communication. It is off and off. Second one is radio technology. Radio signals. This is the one of the working concept. Radio technology. So direct sequence and spread spectrum. Direct sequence spread spectrum. Spread spectrum concept. Spread spectrum concepts are mainly 2 types, frequency hopping spread spectrum, direct to sequence spread spectrum. So here 802.11b based on direct to D triple S, FH double S, and 802.11a and G based on orthogonal frequency division multiplexing. So 802.11b based on spread spectrum concepts. It employs spread spectrum concept, that is frequency hopping and direct to sequence spread spectrum. But 802.11a and G employs multiplexing technique, that is orthogonal frequency division multiplexing. Orthogonal frequency division multiplexing, frequency division multiplexing, nothing but the frequency can divide it into as per our the channels. For example, 50 kilohertz frequency band is there. So the time constant is constant. The frequency is varying, the time is constant. But in TDM, the time is variant. The frequency band is fixed. So this is the main difference between FDM and TDM. So the concept is same. More number of signals can pass through the single channel is the concept is same, but the based on the title it can varies. Time division multiplexing and frequency division multiplexing. So it is implies by 802.A and G. Next one, bandwidth is less than 0.44 bits per second hertz. It is less than or equal to 2.7 bps bits per second for hertz. Next one, in terms of efficient modulation, it is belongs to quadrature phase shift key. So in real time application we use this one, quadrature phase shift keying modulation. This is one of the important digital modulation technique. So currently modulation devices or the communication devices are developed through this concept only, quadrature phase shift keying. This is one of the modulation technique, modulation demodulation technique. So currently communication devices will follow the modulation technique, that is quadrature phase shift keying. Very important one. It follows BPSK, binary phase shift keying, and QPSK 64 quadrature amplitude modulation. It employs by 802.11 A and G. FEC is nothing but none. It is the conventional code. Based on the conventional code, we develop FEC. Encryption data RC24 AES. It is RC4 AES 802.11i. Next one, mobility. In development, we can use the feature of mobility. Same for 802.11 A and G also. It's same. Next one, the mesh one, vendor proprietary. This is same feature. Access protocol also similar. So the among all the features, most of the features are similar, but the difference in frequency band, channel bandwidth, and radio technology. In terms of bandwidth also, it's a little bit variations in between the 802.11b and 802.ARG. So this is the technical comparison between the three major Wi-Fi standards: 802.11, 802.11b, A and G. So these are the comparisons. Let's move on to the quality of service of Wi-Fi. So here there are plans to incorporate quality of service capability in Wi-Fi technology with the adoption of the IEEE 802.E standard. So here we have two operating modes, either which can be used to improve the service for voice. So here two operating modes, the mandatory one is the mandatory, second one is the optional. We may use or we may not use. The first mandatory operating mode is Wi-Fi multimedia extension. Shortly it is WME, Wi-Fi multimedia extension. The optional operating mode is Wi-Fi scheduled multimedia, WSM. This is the optional, we may use or we may not use. Let's move on to the first one is Wi-Fi multimedia extension, WME. So what are the features, what are the applications of multimedia extension, Wi-Fi multimedia extension? So here Wi-Fi multimedia extension use a protocol is called enhanced multimedia distributed control access point, EDCA. So which is an extension of embedded version of distributed control function defined in the original 802.MAC protocol. So it is the multimedia extension uses CA. The concept is EDCA, that is enhanced multimedia distributed control access. It It is the enhanced version of distributed control function defined in the 802.11 MAC protocol. So the enhanced part of EDCA will define 8 levels we have. Like OSI reference model also applies 7 layers of layers, but here the EDCA will define 8 levels of access priority to the shared wireless channel. Next, the original DCF, the EDCA access is a connection based protocol that implies a set of waiting intervals and backup timers designed to avoid collision. The main function of the Wi-Fi multimedia extension to avoid the collisions while transmitting the signals. So there is a collision, compulsory we get some noise or some interference. So to avoid that, we use Wi-Fi multimedia extension. This is the mandatory operating mode. So however, DCF, all the stations use same values, hence have the same priority for transmitting on the channel. So in order to avoid the collision while the transmitting of your signals, we use same values and hence the same priority for the transmitting on the channel. So this is the key point you have to remember for Wi-Fi multimedia extension. Basically, we have 2 operating modes of IEEE 802.E. So the first one is mandatory. Second one is Wi-Fi scheduled multimedia. It schedules some working process. So true consistent delay services can be provided with the optional Wi-Fi scheduled multimedia. It operates little bit point control function defined with the origin of 802.11 MAC protocol. To use WSM option, devices need to send a traffic profile describing bandwidth. Here, describing bandwidth. We confirm the details of bandwidth, latency, and jitter requirements. If the access point does not have sufficient resources to meet the traffic profile, it will be a busy signal. So this is the process of Wi-Fi scheduled multimedia. So this is optional one. We may use or we may not use. First, you have to send the signals. Before that, first you can confirm the sufficient resources with bandwidth, latency, and jitter requirements. If certain bandwidth is okay, the communication is okay. The latency is you can verify along with the jitter requirements. So this is about Wi-Fi scheduled multimedia. The second operating mode, it is the optional operating mode. Next, move on to the IEEE 802.11 architecture. So it is basic architecture of 802.11. So it having stations comprises of all devices with equipment that are connected to the wireless LAN. A station can be of 2 types here. The first one is wireless access point WAP. Second one is the client. Simply, it is known as access points are generally wireless routers that form the base stations or access. So here we have more points extended service set. This is a distributed system. It can distribute the system as per our requirement. It is the access point. From the access point only we can access for internet. So based on that, we have basic service set BSS. Basic service set BSS. What is the function of basic service set? So it is a group of stations communicating at the physical layer level. Bases can be 2 categories depending upon the mode of operation. Again, basic service set, again 2 types. It is infrastructure BSS and independent BSS. So what is that? Infrastructure BSS and independent BSS. So independent BSS devices communicate with other devices through the access points only. But in the independent BSS, the devices communicated peer-to-peer communication basis in an ad hoc manner. So basically, basic service set, depending on operating mode, it can two types of BSS. The first one is infrastructure BSS and second one is independent BSS. In infrastructure BSS, the devices through the access points, but in independent BSS, it can independently operate. So that is a peer-to-peer basis in an ad hoc manner. Next one, extended service set. It is connected to all BSS. Distributed system, it connects all the access point in ESS. So this is about IEEE 802.1 architecture, the basic terminologies involved in the architecture. ESS, extended service set, to STS station, AP for access point, BSS basic service set, to infrastructure BSS, independent BSS, extended services, and a distributed system. So this is about the basic terminology of IEEE 802.11 architecture. But we need to know more information on the architecture of 11. So this is some more information of architecture. So it is a set of media access control and physical layer, specifications for implementing wireless local area network computer communication in the 900 megahertz and 2.4, 3.6, 5 and 60 gigahertz frequency bands. So in the architecture, what are the terminology in the previous slide? What are the terminology involved in the architecture of 802.11? But here, what is the process? What is the application? How much it is frequency? It having frequency band with the range of how much speed in the communication, 900 megahertz and 2.4, 3.6, 5, 60 gigahertz frequency band. It consists like that, having some frequency bands. The IEEE developed an international standards for WLANs. Its standard focuses on two layers of OSI reference model, that is physical layer and data link layer. The Wi-Fi can communicate, or the Wi-Fi can depends on only two layers of, generally OSI reference model having 7 layers. For Wi-Fi, we may use physical layer and data link layer. And the main objective of IEEE 802.11 standard has to define medium access control MAC, sublayer and MAC management protocol and services. So this is some more information of IEEE 802.11 architecture. First, it is a set of media access control and physical layer. It focuses on OSI reference model of physical layer and data link layer. Next, move on to some more information of architecture. It support network where most decision making is distributed to mobile stations. And this type of architecture has several advantages also. It is tolerant of faults in all of the WLAN equipment and eliminates possible bottlenecks as a centralized architecture would introduce. So when you use centralized network, it is compared to traditional network. The centralized network having more advantages to communicate the other devices. So here centralized architecture would be introduced. So the architecture is flexible and can easily support both small and transient network and large semi-permanent networks. So this is about some more information of IEEE 802.11 architecture. Next, move on to the two network architecture in the 802.11 standard. Here, infrastructure network and point-to-point ad hoc network. So we already know the terminology we already know. So the basic details are the complete details of infrastructure network and point-to-point network here. And infrastructure network is the network architecture for providing communication between the wireless clients and network-wide resources. But in point-to-point network, ad hoc network is the architecture that is used to support mutual communication between the wireless clients. So when you, if you see the diagram, this is the distributed system. This is the access points. From the access point, we can have basic service sets. All the devices from the basic service set. So this is for the distributed system. We have service access points. From the access point, we have different stations like station, access point, basic service set, and extended service set. Okay, so this is the network architecture of 802.11 standard infrastructure network and point-to-point ad hoc network. Next, the last three topologies. So generally 802.11 IEEE 802 support basic three topologies here. So the first one is independent basic service set, IBSS, basic service set, and extended service set. So these are the three topologies. In the independent basic service set, it having referred to an independent configuration or ad hoc network. The IBS configuration is analogous to peer-to-peer office network, which no signal node is required to act as a server. The implementation cover a limited area and is not connected to any large network. So it is a very limited, very small network. It is applicable to very small network. It is not applicable for very large networks. So this is the one topology which is supported by IEEE 802.11 independent basic service set. The second topology, basic service set. So here, for example, if you want to send the information from station 1 to station 4, the first it is access from access point 1. From access 4, then station 4. If you want to send some information from station 1 to station 4, the process begins from here to here like that. Like this. So this is about basic service set. The basic set configuration relays on an access point that acts as the logical service for a single local area network cell or channel. An access point performs a bridging function and connects multiple WLAN cells or channels and connects WLAN cells to a wide enterprise local area network. So this is the basic operation of basic service set. The last topology here, extended service set. So the same diagram from previous slide. So it is multiple basic service set, cells that can be linked by either wired or wireless backbones called a distributed system. The same points here I mentioned from the previous slide only. So this is the one of the topology which is supported by IEEE 802.11. So basically three types of topologies: independent basic service set, basic service set, and extended service set. So these are the frame format of 802.11. So we already know frame format, which is already studied in the first second lecture also. So the frame format of 802.11 compulsory it having starting from frame control to duration, address 1, address 2, address 3 sequence, the last one check sequence. Start one by one, step by step. So the main fields are frame control. So the occupation of frame control is 2 bytes. 2 bytes starting field composed of 11 subfields. It contains control information of the frame. So what is the main function of frame control is it controls the information of the frame. Whatever it may be, it can control. Next, duration. It occupying 2 bytes of field that specifies the time period for which the frame and its acknowledgement occupy the channel. It having only 2 bytes of information. Next, address fields. Address fields, address 1, address 2, address 3, address 3. Same equal amount of bytes it can occupy on the frame. 6 bytes, 6 bytes, and 6 bytes. There are 6 bytes address fields containing address of source, immediate destination, and final endpoint respectively. First 6 bytes for source, second 6 bytes for immediate destination, third 6 bytes for a final end point respectively. Next, the sequence having 2 bytes to occupy stores the frame numbers. Next one, data. This is variable seized field that carries data from the upper layers. The maximum size on the data field is 23112 bytes, but in the channel width having 1400 bytes. This is the difference. The last check sequence, it is a 4-byte field containing error detection information. So error detection means we are having Hamming codes, error detection codes in the communication. These are the two error detection codes available in the digital communication: Hamming code and Hamming code. So this is about frame format of IEEE 802.11, starting from frame control, duration, field address, sequence, data, and check sequence, along with how much amount of bytes it can occupy to store the information, to process the request. So this is about frame format of IEEE 802.11. So these are the one of the protocol of link layer IEEE 802.11 is nothing but Wi-Fi. So these are the references for this section 5 references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.